In water supply engineering, unit 2, conveyance system. In this unit, we see about water supply intake structures, functions and drawings of intake structures using various pipe materials, hydraulics flow, transmission of main design, laying, jointing and testing of pipes, drawing upper tunnels and types of capacity of pumps, selection of pumps and pipe materials. Intake structures. The basic function of intake structure is to help in some withdrawing water from the source and then to discharge this water into the withdrawal conduit through which it reaches the water treatment plant. It is constructed at the entrance of the withdrawal conduit and thereby protecting it from being damaged by ice and debris. Sometimes from reservoirs where gravity flow is possible, water is directly transmitted to the treatment through intake structure. If gravity flow is not possible, water entering intake structure is lifted by pumps and taken to the treatment plant. Intake structures. Before that, factors governing the location of intake structures. As far as possible, the site should be near the treatment plant so that the cost of conveying water to the city is less. The quantity of water is must because throughout the year we supply the water to the nearby city. The intake must never be located at the downstream or in the vicinity of the point of disposal of wastewater. When it becomes necessary to locate the intake in the close proximity of the disposal of a drain, it is advisable to construct a weir or a barrage upstream of the disposal point and install the intake upstream of the barrage. Site should be near the treatment plant to reduce conveyance system. Intake must be located in the purer zone of the source so that best quality water is withdrawn from source to reduce the load of the treatment plant. Intake must never be located in the vicinity of this water disposal point. Intake must never be located near the navigation channels so as to reduce chances of pollution due to waste discharge from ships. The site should be such as to permit greater withdrawal of water if required in future. Intake must be located at a place from where its city draw water even during the driest period of the year. The intake site should remain easily accessible during floods and should not get flooded. The intake should not be located on curves or at least on short curves. Types of intakes. Simple submerged intake towers, medium-sized river intake structures, canal intake, river intake for sluice waste of dam. Simple submerged intake. This is the simple submerged intake. A simple submerged intake consists of a simple concrete or a rock-filled timber crib supporting the starting end of the withdrawal pipe as shown in your picture. The withdrawal pipe is generally taken up to the sump tail at shore from where the water is lifted by the pumps. The intake opening is generally covered with screen. Here is the bar screen. It is prevented to entry the debris, ice into the withdrawal conduit. In case of lake where silt tends to settle down, the intake opening is generally kept at about 2 to 2.5 meters above the bottom of the lake. and thus to avoid the entry of large amount of silt and sediment. Such intake structures should be placed in streams or in lakes at a place where they may not get buried under sediment and where there are deep waters. Next, rock-filled submerged intake. Rock-filled submerged intake or generally do not obstruct navigation. They are therefore widely used for small water supply projects drawing water from streams or lakes having relatively little change in water surface elevation throughout the year. These intakes are not used on bigger projects on rivers and reservoirs as their main disadvantage is the fact that they are not easily accessible for cleaning, repairing works. Next, intake towers. Intake towers are generally classified into two types. One is wet intake tower and another one is dry intake tower. Wet intake tower. A typical section, this is the wet intake tower diagram. A typical section of a wet intake tower, it may consist of a concrete circular shell filled with water up to the reservoir level here, up to the reservoir level, and has a vertical inside shaft which is connected to the withdrawal pipe. The withdrawal conduit may be taken directly to the treatment plant in case no lift is required, that is in reservoir. The withdrawal conduit may lie over the bed of the reservoir or may be in the form of tunnels below the river bed. Openings are made into the outer concrete shell as well as into the inside shaft as shown in the figure. Gates are usually placed on the shaft so as to control the flow of water. Here, the gates. These two gates are control the water to enter into the conduit. The water coming out of the withdrawal conduit may be taken to pump house or lift. If the city's water treatment plant is located at high elevation, may be taken directly to the treatment plant if it is situated at a lower elevation. Next, dry intake towers. This is the dry intake towers diagram. The essential difference between a dry intake tower and a wet intake tower is that whereas in a wet intake tower, the water enters the entry force into the tower and then it enters into the conduit pipe through separate gate controlled openings. In a dry intake tower, the water is directly drawn into the withdrawal conduit through gated entry ports. See, here is the gated entry ports. This is the difference between the wet intake and dry intake. Here is the entered into the gated into the shaft and dry intake. This is the entry port. It's directly entered into the conduit. This is dry intake towers. They are generally constructed of withdrawing water almost all towers. One twin well type of intake structure and then single well type of intake structure. Twin well type of intake structure. This is the twin well type of intake structure. One well is intake well and the another well is called sump well or jack well. This is the most commonly used type of river which is generally constructed on almost all type of rivers. Such a condition is usually available on non-alluvial rivers, while in meandering alluvial rivers, such a condition can be obtained by constructing a weir across the river as to store water up to pond level, thus making it available near the river bank on the under sluice side. Next, single well type intake. No inlet well and inlet pipe in this type of river intake. Opening or ports fitted with bar screens are provided in the jack well itself. The sediment entering will usually be less since clear water will enter the takeoff channel. The silt entering the jack well will partly settle down in the bottom silt zone of jack well or may be lifted up with the pumped water since pumps can be easily lift sedimented water. The jack well can be periodically cleaned manually by stopping the water entry into the well. This is the cross section of single well type intake structure. Here we see only the sump well only here. Here sump well and jack well is available. Then only it's called twin well type, and this is called as a single well type intakes. Next, canal intakes. In case of canals, the intake well is generally located in the bank of river canal and water enters the chamber through an inlet pipe combined with a fine screen. The water coming out of the chamber through the outlet conduit may be taken to a sump well or city. Since the flow area is obstructed by the construction of intake well, the flow velocity of the canal increases and hence pitching will be needed on both upstream and downstream portions of intake. The entry of water in the intake is through a coarse screen withdrawal provided at minimum water level in the canal and is above the above canal bed level to avoid entry of soil. An additional fine screen is provided at the inlet end of the withdrawal conduit. An outlet valve operating from the top is provided to control the entry of water into the outlet pipe. This is the cross section of canal intake structure. Intakes for sluice ways of dam. In case a reservoir is developed by constructing a dam, it is a practice to fetch water through the sluice ways from inside the dam. In case of earthen dams, the intakes for withdrawing water into the sluice way of the dam is generally located near the upstream toe of the dam. But for a masonry dam, the intake well for withdrawing water is generally located inside the body of the dam. Sometimes for earthen dams, the wall towers or intake wells are provided within the body of the dam. In all these arrangements, the intake conduits are installed all different levels and it enters into the common conduit such a way or a tower and then the water will continue to the sluice way of the dam. The intake conduits are controlled by valves which can be operated from the control room. This is the intakes for sluice ways of dam. Here we collecting the water in all the different levels like normal water level, maximum water level and minimum water level. These are all the three ways we collecting water, but one sluice way to take the water into the treatment plant. And the next, intakes for sluice way of dams. This is the another one, masonry dams example. Next, intake for sluice ways of dams. Here is the wall tower situated with an earthen dam. Next, we see the classes about conduits. Conduit is a conveyance system to transport water through or around under a dam. Water can be conveyed by open channel flow or pressure flow. Conduits are generally located within an embankment of the dam. Types of conduits, gravity conduits, pressure conduits. Gravity conduit, the flow or movement of water takes place by force of gravity. The gravity flow in this type of conduit is achieved by providing suitable hydraulic gradients. Then open channel. We see the open channel. These are rarely used to transport the water from the source to treatment plant. These can be effortlessly and cheaply constructed by cutting in created grounds and banking in low grounds. The channels should be prevent the seepage and contamination of water, as water flows only due to gravitational force. Hydraulic gradient line in channels touches the water level at every place. Velocity of water in channels should not exceed the permissible limit, otherwise scoring will start in the bed and water will get dirty. In channels, there is always loss of water by seepage and evaporation. This is the typical flumes. Addicted pressure conduit. The pressure conduit is a closed conduit where no air is allowed to enter into them. Water flows under pressure higher than the atmospheric pressure. These are all the two types of conduits. In next class, we see about hydraulics flows in pipes. Thank you.